This is Joe Wischlater with Wischlaters Incorporated, and in this video tutorial we'll be going over figuring out what coordinate system a LiDAR tile is using so that we can import it into FarmWorks properly. Every now and again the LiDAR files might have been collected and not in a state plane coordinates. Most of the video tutorials that I have prepared use a local state plane coordinate system. We'll look at this county in southern Illinois that does not use a state plane. So if you import a tile and it doesn't come in properly, you might need to use this method. So I just downloaded a tile and it's currently in my downloads folder. So I will go ahead and go to my downloads folder. I can see this tile that we just downloaded. So I will cut that out. I'm going to paste it in my tiles folder just like normal. And so now, before I open up LASTools, you can see, or my LAS to text tool, I'm actually going to go to my LASTools folder. I got that saved on my C drive. I'll open up the bin, and there's a tool called LASinfo. So when you're not sure what coordinate system you're in, you can use the LASinfo to figure out what you're using. So I'll open up LASinfo. And on this menu on the left hand side, it's same as the LAS to text. So we'll type in C:/tiles and hit go. So here is this tile right here. The output file, the directory, I'm going to put it C:/tiles. And that needs to be a colon, not a semicolon. And the file name, I'm just going to call it info.txt. And now I'll hit run 32. And start. And so what's going to happen is it's just going to give us a printout of the info of this tile. So there's that info text file. I'm going to open it up, and as you look down through here, it'll show you a number of information. You know, how many points are there, project ID, date, you know, all this type of stuff. But what we're looking for is a coordinate system, and right here I found it. It's showing us NAD83 UTM zone 16. The projection is the transverse Mercator, and the elevation is nav D88 geoid 9, and it's in meters. So I could bring this file, you know, I could convert it into a text file and bring it right into FarmWorks. However, it's in meters, and I want it in survey feet. So I'm going to show you how to convert this into a text file and get it out of meters and into survey feet. So I'm just going to leave this over here for now. We might refer back to it. And I can now close out of this LASinfo, and I'll open up my LAS to text. So I can click browse, type in my C:/tiles, and there's my file. I'm still going to add my filters just like I normally would. I'm going to first put a keep classification of 2, and then I'm going to add keep every nth. I'll choose every 25th point. So there's my filter. I am going to transform it. Normally we don't have to. If your coordinates are already in elevations in feet, we don't have to transform it. But I'm going to transform the coordinates. I'm going to scale Z. So by scale, we'll basically multiply. Now the multiplier from meters to US survey feet is 3.28084. And I'll hit add. So it's going to scale our Z by 3.28084, which will convert the meters to US survey feet. And now I'll just set its projection. It is UTM. You need to look at a UTM zone map to know where you're at. We're in zone 16, and actually if I go to that info, it shows me I'm UTM zone 16. N means northern hemisphere, so we have northern hemisphere checked. My datum is NAD83, because we can see that from our datum, NAD83. Our elevation units are in meters, so we can see that in meters right over here. Our vertical datum is NAVD88, so I'll select NAVD88, and the geoid model is geoid 9, so I'll select geoid 9. So now I've got all the information selected that came off that info. So I'll minimize the projection. And we'll do the same thing. You know, I usually put merge files into one, which gives it its file name, and the directory is going to be C:/tiles. And we'll minimize the output and hit run. and is now converting it into a text format. So we can open up in FarmWorks. I'll create a sample field, new field. I'll call it sample field, if I spell field correctly, 2. And we'll import that background. That was on my C drive in the tiles folder. And there's my merged file. So this time it's not in a state planes coordinate system, it's in a UTM coordinate system. So I actually have a template set up for UTM 16. System is UTM, zone is 16 Northern Hemisphere, datum is NAD 1983, and then we have our easting, northing, and elevation. And as I hit OK, it will import that merged files, and I double click on it. The merged file should line up with the aerial photography. So we'll give the aerial photography a second to load. I notice I can look at my elevations. It's in that 4 to 500 foot range, which is accurate for the given location. I can also notice that initially, looking at this kind of low ground, this channel is all matching here. So we are able to convert that and filter it and modify the elevations properly. So I hope this has helped you in this process. If you have any questions, certainly let us know.